So, now let us take an example of a particular circuit, and depending on the example we will see how the whole method of analysis goes on. So, let us take the example of this circuit. This is a standard circuit comprising of 2 voltage sources and 3 resistances, and as you can see, one resistance I have marked as RL. RL means, RL is basic, RL is a very distinct notation and it means precisely the load resistance in case of electrical engineering. So, that means this is your point of interest, the whole problem is going to revolve around this RL. Now, how are you going to distinguish the RL from other resistances and stuff? In most of the cases you will find, for example, if you are concentrating on your exams and stuff, in most of the examples you will find that you will be asked to calculate the voltage or current or power across a particular resistance. So, that resistance is your point of interest, or rather the RL. And in real life, for example, you have to analyze the output input characteristic of a particular device which is consuming the power, for example, a motor. Then the total internal resistance of the motor itself, or the point of resistance, or the point where the motor is connected, that will be considered as a single resistance, and that will be your point of interest. You have to analyze the whole thing due to that point of interest. Keep that thing in your mind, that RL is a very important thing, and to distinguish and understand the RL is a first major task while you try to solve a problem using either Norton or a Thevenin's theorem. Okay. So, in this case, this is the load resistance RL. Now, what is the first step? The first step while doing or trying to solve the problem using Norton's theorem is to identify the RL. Next, once you are done with identifying the RL, you have to remove the load resistance. It will be removed by using an open circuited terminal. So, you see, previously there was a RL placed in this particular position, now it has been open circuited. So, you are done with the first step, distinguishing and removing the RL from the circuit. Now, the circuit somehow looks like this. Now, we have to do some calculations, certain calculations and things, so that we can ultimately try to find out these 3 parameters. See, in this case already we have found out the first parameter of our necessity, the RL, it has already been found out, you know what is the value of RL. Next is the RN and the ISC. Now, how to calculate RN? RN is the total internal resistance of the circuit, and it has got, there is a particular method to calculate the RN. While you try to calculate the RN in the main circuit, what you have to do? You have to remove all the sources with their total internal resistances. Now, in case of an ideal voltage source, it is considered that the total internal resistance of an ideal voltage source is always 0, and in case of a ideal current source, it is considered that the total internal resistance of an ideal current source is infinite. So, that is why whenever you have to remove the voltage source or current source from a circuit, it is conventional in more or less it is conventional to remove the voltage source by a short circuit and a current source by an open circuit, except in those cases when you are provided with the internal resistance of the sources itself, then you have to replace the sources with their internal resistances that has already been mentioned to you. So, in this case, as we are not mentioned, and this is the most conventional method, we are just removing the sources by using their internal resistances. So, in this case it will be a simple short circuit between these 2 points, and in this case also a short circuit. Now, a question may arise, if for example, this was not this, currently this is a voltage source that we have already replaced. Now, if it would have been a current source, then what could we have done? It is very simple. In that case, we would have left the circuit just like that. Why? Because you always replace a current source by using a open circuit, but in this case, as it is a voltage source, we are simply short circuiting it. So, now this is how the circuit looks like before we start calculating the total internal resistance of the circuit. Now, calculating the total internal resistance of the circuit has a particular method. You have to look into the circuit from the open circuited load terminal to find out what is the value of the total internal resistance of the circuit. Now, what is the significance of looking into the circuit? As we have already discussed in the Thevenin's class, see, the whole alignment of the circuit changes depending on the method you are looking into the circuit. For example, if I look into the circuit from this end, if we look into the circuit from this end, what happens? This resistance and this resistance both becomes in series to each other. Why? Because this is an open circuited terminal, no current is going to flow through this. So, this one and this one will be in series, right. But if I have to look into the circuit from this particular terminal, then what happens? For your sake of understanding, let us consider a current is flowing in this direction like this. What happens once it reaches this? It gets divided into two directions, and whenever current divides, then that means those branches are in parallel. So, in this case, this R1 and R2 are acting as parallel resistances compared to the previous case. So, you see, just depending on the position of our eye or the position of the analyst, the whole alignment as well as the value of the internal resistance gets changed. So, that is why this important phrase is there. You have to look into the circuit from the open circuited load terminal, that is very important. So, in this case it simply it will be R1 parallel R2, that will be equal to R1 R2 by R1 plus R2. So, that will be the value of the total internal resistance of this circuit in this case, fine. So, Rn will be equal to this. So, now we are done with two things. One, we have identified the RL, removed it from the circuit, and also we have calculated the Rn with the standard methodology. Now, we are left with only the ISC or the short circuit current. Now, we have to see how we are going to calculate that in case of this circuit. Now, when you try to calculate the ISC, it has got a very standard method for calculation. What do you have to do? You have already removed the load resistance for the previous case while you try to calculate the Rn. In this case, you have to just simply short circuit that load terminal, and also again you have to place the sources that were present originally in the circuit, and then you have to find out what amount of current is actually flowing through this short circuited terminal. The amount of current, for example, in this case if it is x ampere is flowing through this, will be the value of the current source ISC. That is the straightforward rule to calculate this. So, as you are already familiar with how you are going to calculate the ISC, Rn and RL, there are different methods based on the circuit, based on the demands of the circuit, by using KCL, KVL, node analysis, loop method, anything that you are comfortable with. You have to find out the amount of current that is flowing through the short circuited load terminal, and that will be equal to your short circuit current, the value of this current source ISC. So, more or less we are done with calculating all the parameters necessary for this circuit, for the standard Norton circuit, that is ISC, RN and RL. Once you are done with this, here remains the final task to calculate the load current IL. What amount of current is flowing through this load? So, that is nothing but that is a very easy calculation, that is equal to ISC into RL by RL plus RN. Very basic rule of current division. Once you are done with this, see, in this case the amount of current you are getting is exactly the same amount of current when a load is connected in this position. The same amount of current is flowing through this, and while doing so it is much easy while you try to calculate the current from this one compared to the original one, while you try to do the whole calculations directly from the original one. And there is another also very interesting relationship between the standard Norton and the Thevenin circuit. See, VOC is called the open circuited voltage or the VTH, and this is a standard parameter in case of a Thevenin circuit, and there is this ISC, it is called the short circuited current source, or the value of the short circuited current source, and it is a very important parameter of the Norton circuit. Now, if we just simply divide the VOC by ISC, you will get another very important parameter of both the circuits, that is the total internal resistance of the circuit itself, and it is a universal conventional relationship. So, keep that in your mind. So, that is all about the basic operations of the Norton circuitry. Once let us get a brief recap. First of all, what you have to do? You have to understand the position of the load resistance. Once you have identified the load resistance, remove the load resistance from the circuit and calculate the total internal resistance of the circuit considering all the other elements and removing the sources with their total internal resistance. Then the last one, you also have to remove the, for this case you also have to remove the load resistance, but in this case you have to remove it by a short circuit, and you have to calculate what amount of current is flowing through that short circuited path, and the value of the current will be equal to the ISC or short circuit current source that is necessary for the analysis of the Norton's theorem. Once you are done with this, apply the simple current division law to find out what amount of current is flowing through the RL. Thank you.